This is the answer key for Castle Unit 3 Worksheet 1. And in the circuit shown in Figure 1A, bulb A and B are identical and have high resistance. And it says to draw arrow tails and starbursts on the bulbs in Figure 1A. Okay, so let's just start with this. Okay, so if they're identical, then they ought to light up the same. And they ought to have the same amount of flow through them. So let's say this one has, boy, this is not really a lot of space. Normally I'd put this above or below the bulb, but I'm going to put it in the space there. So remember that by conventional charge flow, the charge moves away from plus and towards minus, kind of like this. And so I'm going to put 3 arrows worth of flow next to that bulb and 3 arrows worth of flow next to that bulb. And then for B, it says a third identical bulb C is added to the circuit as shown in Figure 1B. Draw arrow tails and starbursts on Figure 1B, consistent with the ones in Figure A. So what they're saying is there's no right answer to 1A and how we do things, as long as the key features are the current, the flow rate through each bulb should be the same, so you should have the same number of arrow tails, and the brightness of each bulb should be the same, so you should have the same number of bulb rays. But whether you put 3 or 2 or 4 or 1, it doesn't really matter. But in Figure 1B, it says be consistent with 1A. So what we're saying is, when you add this bulb in series, remember when we add bulbs in series, the flow rate decreases and the bulb brightness decreases, the overall resistance of the circuit increases. So being consistent with 1A means that we're going to say that, hey, the bulbs are now dimmer. So I'm going to just draw something showing that the bulbs got dimmer. So now instead of 3 little rays coming out of each bulb, or 6 little rays, I'm going to have 4 little rays. And likewise with the current, instead of having 3 little arrows worth, I'm going to say, hey, let's only have 2 little arrows worth now. Okay? Part C, compared to bulb A in Figure 1A, bulb A in Figure 1B will be dimmer. And compared to bulb B in Figure 1A, bulb B in Figure 1B will be dimmer. So the key to this question is understanding that adding bulbs in series increases the resistance of the circuit. Does the amount of charge, as number 2, does the amount of charge stored in a charge capacitor depend on the type of bulbs through which it was charged? The amount of charge. Well, the answer to that is no, and the experimental evidence that we did was you did an experiment where you charged the capacitor so let's say this is capacitor A with round bulbs, and you charge capacitor B with long bulbs. And then you discharge each capacitor with a Genicon. Discharged each capacitor with a Genicon and then counted the number of turns it made. And it turns out that if this one made 3/4 turns, then B also made 3/4 turns, which suggests that the amount of charge on the capacitor is exactly the same. It just takes longer to charge the capacitor with the long bulbs than the round bulbs because the flow rate is higher through the round bulbs than the long bulbs. Okay, the experiment question. Suppose you are given new bulbs, brand X, which are different from the round and long bulbs. Design an experiment that you can determine how the resistance compares to that of the round and long bulbs. There's probably several different things you could do. You could, I wonder if that's even in the recording right there. You could just go ahead and light the bulbs. Let's say brand X, and compare the brightness. You could stick a compass in the circuit and look at the compass deflection. Or you could use the bulbs in a charging circuit for the capacitor. And then you'd compare this with circuits that have round bulbs or circuits that have long bulbs and interpret your results. I'm going to use compass deflection as my example. So if you looked at compass deflection, if X has a higher compass deflection than the long bulbs, than the round bulbs, then X has, well, let's think about this. If you have a higher compass deflection, that means you have a higher flow rate, and high flow rate means lower resistance. Lower resistance. Likewise, if the X bulbs have a lower compass deflection than the long bulbs, then they have a higher resistance than the long bulbs. For number 4, it says a capacitor is charged through 2 bulbs and discharged through a single bulb. This is kind of like the experiment where you charged with long bulbs and discharged with round bulbs, by the way. So show appropriate starbursts and arrow tails for each circuit. Well, we're going to see, initially anyway, I realize what's going to happen is these things are going to change as time goes on. You would see initially a bright bulb and a lot of current. And then through this one you'd see probably an even brighter bulb and even more current. Mark each of the following statements as true or false. If it's false, edit the statement so it becomes true. Okay. More charge flows through the single bulb than through the 2 bulbs. This has to be 2 bulbs together, by the way. 2 bulbs combined. Does more charge flow through the single bulb than through the 2 bulbs combined? That would be false. Okay? It's the same amount. This is the, on the previous page, this is the question with the Genicon generator. Charge flows at a greater rate through the single bulb than through the 2 bulbs. That is true. Because, why? Because these 2 bulbs are in series with each other. So there's a higher resistance with 2 bulbs, which means that there's a lower flow rate through the 2 bulbs. So there's a higher flow rate through the single bulb. Single bulb shines brighter than either bulb in the 2 bulb circuit. That is true, because when you add more bulbs in series, you will decrease the brightness of the bulbs overall. The total resistance of the 2 bulbs is greater than that of the single bulb. That is true. And again, when you add bulbs in series, the resistance increases. That is the equivalent of adding a longer wire, right? A longer resistor. So increasing the length of the resistance increases the resistance. A compass would show a larger deflection for 2A than for 2B. That is false, because 2A has a smaller flow rate than 2B, at least initially. Right? At the end, neither one's going to have any flow rate. So the compass would show a smaller deflection for 2A than 2B. And that's the true-false section.